All right, guys, welcome back. This is going to be the 6.3 instructional video. And as you can see on the board, we are going to talk about standard form today. Where are we in the context of our lessons? Well, in 6.2, the previous section, we learned about slope-intercept form. And this is all broadly a part of our different ways of looking at equations of lines. Slope-intercept form was the first equation of a line we looked at, and now we are going to look at standard form. And the question may be, well, Mr. Carter, we kind of like slope-intercept form. We learned about slope-intercept form a lot in middle school. Why are we going to talk about any other forms? Well, different forms are good for different things, and you're not always going to have the same information. You think about slope-intercept form, what do you have to have in order to graph something in slope-intercept form? We got to know the slope and the y-intercept. Well, what happens if we're in a situation we don't know the slope and the y-intercept? These are situations that may require us to work in a different form. Now, the forms aren't standalone, and we're going to learn how to switch between the forms. They do relate to one another. They're not just completely isolated concepts. We're going to learn how to transform between them toward the end of the lesson. But for now, we're going to talk about standard form. So what do we need standard form for? Well, standard form is useful for quickly making graphs. Okay, we are going to quickly make graphs, and we're going to do this by finding the x and the y intercepts. Definitely make sure you have the 2 bullet points written down. We want to find the x and the y intercepts. Okay, plugging in 0 for y and solving for x, and plugging in 0 for x and solving for y. Now, why do I have that little bit in there? Well, let's think for a second. If I have a graph, and if we look at the blue line here, and the green line, and the red line, what you're going to notice is they cross the x-axis at different points. Every single one has a different x-intercept, right? If we think back to the terms x and y intercept, intercept is where we cross the axis. So the x-intercept is where a line crosses the x-axis, okay? And if we look here, all of our different lines, the red one, the blue one, and the green one, cross the axis at a different x-coordinate, right? The blue line looks like it's going right through the origin. The red line looks like it goes through maybe at +1. We didn't really put a scale on there. If the red one crosses at +1, then maybe the green one crosses at 4 or 5. Either way, they're crossing the x-axis at different x values. But what do they all have in common? Well, no matter where a value crosses the x-axis, that moment where they cross the x-axis, they will have a y value of 0. Now, the x value will change, right? You can cross the x-axis at different places, horizontally speaking. The x-coordinate will be different. But the y value when you cross the axis will always be 0. Hence, we can find the x-intercept in any equation by figuring out or by plugging in 0 for y. Why would we do this? Well, remember, linear equations have 2 variables. And with those 2 variables, if we can plug 0 in for one of them, now we have a 1-variable equation that we learned how to solve in Chapter 2. Seem confusing? We'll look at an example in a second where it'll get more practical. But the same also occurs for the y-intercept, right? Just like for the x-intercept, where you hit different points on the x-axis, but the y value is always 1. If we look at where these lines are crossing the y-axis, again, the blue line goes through the origin, the red line slightly above the origin, the green maybe all the way down here, right? It'll eventually hit the axis because it is not a special type of line, okay? The y-intercept, while it will hit in varying heights, in varying degrees vertically, it will come into contact with the y-axis at varying heights. Whenever the y-intercept occurs, the x value will always be 0. The x value will always be 0. That's why we say when we find the x and y intercepts, what we're going to do is plug in 0 for y to find the x-intercept, aka solving for x. And we're going to plug in 0 for x, aka, and solve for y, aka finding the y-intercept. Okay? And this is how we are going to graph equations in standard form. Standard form, by the way, is ax plus by equals c, where a, b, and c are going to be real numbers. A, B, and C are going to be real numbers. Now, typically, we like to write them as integers if we can. I can't always guarantee and tell you that A and B are going to be whole numbers, but typically, if we're working with fractions, we'll like to get rid of them so that A and B can be whole integers. And we'll see more of that in a bit. But equations like 3x plus 4y equals 8 are in what we call standard form. And again, to quickly graph this, what we're simply going to do is find the x and the y-intercepts. That'll give us 2 points on the graph that we can connect with a line, and we'll get a picture of what the graph of the equation in standard form looks like. Okay, we do this as opposed to trying to maybe turn this into slope-intercept and going through the work of getting y by itself. So let's look at an example. Before we ever get to graphing, let's get some more practice with the x and y intercepts. I want you to try this on your own. See if you can find the x and y intercepts of 3x plus 4y equals 8. Well, hopefully you've given it a shot yourself. And when we see find the x and y intercepts, where hopefully our brains go, though new, is to the idea of, okay, what do I know about an x-intercept? Well, I know it's where we cross the x-axis, but how does that help me in solving? You see, we don't know how to solve equations with two variables, but we can find specific values if we only have one variable, which is where it's helpful for us to remember that not only is the x-intercept where we cross the x-axis, but when we cross the x-axis, our y value will be 0. Similarly, your y-intercept occurs when your x value is 0. So what are we going to do? Well, to find my x-intercept, I am going to plug in 0 for y. I'm going to plug in 0 for y. When I do this, I get 4 times 0 is 0. So I just get 3x equals 8. From there, I divide both sides by 3, and I get x equals 2.67. 2.67. And that will be my x-intercept, aka at the point 2.67, 0, I am going to cross the x-axis. This is where my x-intercept is going to occur. Similarly, to find the y-intercept, I will set x equal to 0 and solve my equation. 3 times 0 is 0, which leaves me with just 4y equals 8. Divide both sides by 4, and I get y equals 2. Again, what does that mean? That means my y-intercept is occurring at the point 0, 2. So I have where I would cross my y-axis, where I would cross my x-axis. Okay? And this process will work no matter what form of linear equation you're working with. It's not just exclusive to standard form. No matter where you are working, okay, your x-intercept can be found by plugging in y for 0, and your y-intercept can be found by plugging in x for 0. Okay, let's take it a step further. See if you can, now that we've learned how to find x and y-intercepts and we've gone through an example, see if you can take it to the next level, use your knowledge of finding intercepts to graph following or the above equation in standard form. Okay, so hopefully you've paused the video and taken a chance to do that. In order to graph equations in standard form, what we do really quickly is, for quick graphing, we're going to find our x and our y intercept. Again, my x-intercept occurs when y equals 0. So I'm going to plug in 0 for y. That leaves me with 2x equals 12, aka x equals 6, which means at the point 6, 0 is where my x-intercept of the following equation in standard form occurs. Y-intercept, I'm going to set x equal to 0. So 2 times 0 plus 3y equals 12. 2 times 0 is 0, leaving me with 3y equals 12. Which gives me y equals 4, which means my y-intercept is at the point 0, 4. So I go to 0, 4. I'm going to plot a dot, and then I'm going to connect them with a line. Okay? And this will be my graph for the linear equation 2x plus 3y equals 12. Okay, let's keep going. Now, if you're really up for a challenge, pause the video and see if you can figure this one out. See if you can figure out how do we graph y equals minus 3. So hopefully you've given it a shot at this point. And this one's really difficult. And I alluded to this in a previous lesson. We've looked at a couple of these before. But this one's tricky. If we think back, we know, okay, we think back to this, we go, okay, we're working in standard form here. We're working in standard form. So what elements do we see present in the y equals minus 3 that we see in our equation for standard form? Well, I notice that my c value is minus 3. And I see my y, and there isn't a coefficient written in front of the y, but I know if there's no coefficient written, that really there's a 1 there, because anything times 1 is itself. But what I don't see, what I seem to be missing, is this a times x. Well, if it's not written there, then we can presume it's 0. And specifically, what we don't see written here, because we don't write 0, is that your a value is 0. What we do have here, even though y equals minus 3 looks really weird, as you can see over here, is we really do have an equation in standard form. We do have an equation in standard form. It just looks different because we don't write 1 as a coefficient, and we have a 0 plugged in for our a value. So how are we going to graph this? Well, we'll still graph it the same way. We're going to try and find our x and y intercepts. So to find that x-intercept, we're going to set y equal to 0. So I get 0x plus 1 times 0 equals negative 3. And if you look at this really quick, you're going to see very quickly we run into a problem. 0 times anything is 0, so I end up with 0 plus 0 equals negative 3. That's not a true math statement. There's no solution there. That's not That's not mathematically correct. What does this imply? Well, what are we trying to do? We're trying to find an x-intercept, and we got no solution. What that means is there is no x-intercept present. There is no x-intercept. Well, what's the only type of line that can have no x-intercept? Well, it's a line that's a complete straight horizontal line. Any line with any sort of slope will eventually come into contact with the x-axis. But a horizontal line will run parallel to the x-axis and will never come into contact with it. Now, is there a y-intercept? Well, we should expect one if we're looking for a horizontal line. And indeed there is. To find the y-intercept, we set x equal to 0. 0 times 0 is just 0. And we are left with y equals negative 3. So our y-intercept is occurring at negative 3. And we don't have an x-intercept. And so the graph of our linear equation is going to be a horizontal line at the y value, negative 3. And it will run parallel to the origin. And this should make sense, right? It's difficult to conceptualize, but if we look back at our original equation in standard form with the 0x there, no matter what value you plug in for x, you're going to end up with the same thing every time. If x is 7, you're still going to get 0 times 7 plus 1y equals negative 3. Well, 0 times anything is 0, so I just get y equals negative 3. It doesn't matter what value you plug in for x. Y will always be negative 3, which is why we have this horizontal line. No matter the x value, whether 1 billion or negative 200 billion or anything in between, your y value will always be negative 3. Hence, the graph of it is a horizontal line at negative 3. The shortcut, when you see a linear equation like y equals minus 3, you can automatically jump straight down to that y value, go, oh, y equals negative 3. Okay, I go to my y-axis, go down negative 3, and draw a horizontal line there. Okay? Similarly, we can think about a graph of x equals 2. We can think of a graph like x equals 2. Okay? If we again imagine standard form ax plus by equals c, what we can see is occurring here is, again, we have 1x, we have c, but what we are missing is that 0y. We are missing that 0y. We just don't write it in math. When we have nothing, we just don't write it. Well, if we look to graph this, again, you are probably already imagining what's going to happen, but to find my x-intercept, I'm going to set y equal to 0. What that's going to leave me with is x plus 0 times 0 equals 2. In other words, x equals 2. So I'm going to come into contact with the x-axis here. And then what we're going to run into is if I try and find the y-intercept by setting x equal to 0, I'm just going to end up with 1 times 0 plus 0y, and I end up with the situation, since 0 times anything is 0, of 0 equals 2, aka no solution, aka there is no y-intercept. And again, if we think back to the original equation, what this is saying is no matter what value I plug in for y, you are going to end up with x equals 2. Your x value will be 2. So what's our graph going to look like? This time it'll be a vertical line. Now you might be sitting there wondering, Mr. Carter, why would you not just tell us right off the bat, oh, x equals 2, vertical line, okay? Or why would you not just tell us y equals blank, draw a vertical line, okay? What I want you to understand is kind of where this comes from. If you just memorize it, you could fall into the trap of going, oh, x equals 2. Well, I'm not sure if that's a vertical or a horizontal line. Well, x is the horizontal axis. I'll just throw it at y equals. No, that's what we don't want to happen. Again, we want to think about this, and we can see the reason it's a vertical line is because there is no y-intercept. We can also think about it in terms of no matter what I plug in for y, x will always be 2, which produces that vertical line for us. Okay, now that we have had plenty of practice at graphing in standard form, we're going to transition into the next level of things. We've learned all about standard form, which is, again, ax plus by standard form. We're looking at ax plus by equals c. And what we're looking at is we've learned this, but we've also learned another form of linear equation, slope-intercept form. We like slope-intercept form if we know the slope and the y-intercept. This equation is y equals mx plus b. We really like it when we have a slope and a y-intercept, but that's not always the case. Standard form is nice for quickly graphing, but again, to do that, we got to find both the x and the y-intercepts. Okay? So what you're going to see here is there are certain situations where we want to use one form as opposed to another. One form as opposed to another. So what's good to be able to do is to transition from one form into the next. But in order to do that, we have to recognize what's unique about each form. Now, what do we notice about each one? Well, standard form, there are two things that we want to kind of look out for. Number one, your x and your y value are on the same side. They are on the same side of the equation. It is, in fact, the only form of the three linear equations where x and y are on the same side. The unique aspect of standard form is x and y are on the same side. We also, when we're in standard form, typically would like to avoid fractions. What do I mean by that? I mean, we don't want our a and our b value to be fractions. Typically, standard form will have those as whole numbers. So we might take certain steps to get rid of the fractions. Because as we've seen in previous lessons with slope-intercept form, more often than not, our m value will be a fraction. So what makes slope-intercept unique? Well, this is a bit of review from the last section. But slope-intercept form is the only linear equation form where y is by itself. Y is by itself. It's the only form of linear equation where y is alone. Okay? So why do I bring up these unique features for each one? Well, if we understand the unique features, it's going to help us recognize what form we are in and how to transition into the form we want to. Look at this example. We want to change the equation that is in slope-intercept form into standard form. We want to change the equation in slope-intercept form into standard form. Well, what do we know about slope-intercept form? Well, we can tell this is slope-intercept because it's roughly in the form y equals mx plus b. B being a 2, m being 3/4, and again, y being by itself. What we want to turn it into is standard form. Well, what do we need to do? Well, in order to do this, we need to get x and y on the same side, and ideally, we're going to get rid of the fractions, okay? We will sometimes have fractions for your a and b values in standard form, but again, if we can avoid it, we'd prefer to have whole numbers. Well, how am I going to start this? Well, let's look at getting rid of the fractions, okay? Now, the question becomes, how do we get rid of fractions? And to do that, we need to think about what a fraction is. A fraction, we are dividing two numbers. How do we undo division? Multiplication. So if I want to get rid of this 3/4, I need to multiply by 4. The other logic that uses is we know from our unit conversion lesson, if you multiply two fractions together, aka I take a whole number like 4 and put it over 1, and you are multiplying them together and you have the same thing on the numerator of one and the denominator on the other, they will cancel. Again, we learned about this in unit conversions. You can also check the math here by going ahead and doing your typical fraction multiplication. Do 3 times 4 and get 12. 4 times 1 is 4. 12 divided by 4, again, you're just left with 3. The same thing if you just cancel those, the same numerator, denominator number out because they're being multiplied. So we apply this logic to get rid of the 3/4. I need to multiply the entire left side by 4. Again, an equation is like a balanced scale. We can't quadruple one part of one side and do nothing else. It will leave the scale imbalanced. Rather, we'll quadruple the whole side, and then we'll do the same to the other. So I'm not just going to multiply the 3/4 x by 4. Instead, I'm going to multiply everything by 4, the whole right side and the whole left. When I do this, I'm going to get 4y equals 3x. Again, we've already illustrated why 3/4 times 4 turns into 3x. And I'm going to multiply the 4 by the 2, and I will get 8. Once I've done this, I have now gotten rid of my fractions, which is, again, something we typically like to do with standard form. The last step is I need to get x and y on the same side. So I will subtract 3x from both sides. And I will get 4y minus 3x equals 8. 4y minus 3x equals 8. Okay? 4y minus 3x equals 8. This is now in standard form. Again, 4 is my a value, 3 is my b value, and 8 would be my c value. 8 would be my c value. Okay? That will wrap up this video. As always, let me know if you have questions. Good luck in solving the problems.